You don't have to be a genius to know what sound is and what noise is in general, but how exactly do you tell them apart? Don't these two concepts have anything in common? This is what we are going to explain to you now.
First of all, let's scientifically define sound. Sound is a mechanical wave because it is a vibration that travels through the air. This is why there cannot be sound in the vacuum. It is also progressive because molecules in the air touch each other until they reach your ear. A sound is defined by its frequency f and its intensity s. Graphically, a sound can be represented by a sinusoidal periodic function representing the amplitude in meter as a function of time in seconds. We can define the period of the signal as the time it takes to build an elementary pattern. This is to say a pattern that repeats itself continuously. The frequency f is equal to 1 over the period. Phi is the phase at the origin of the graph. Sound intensity is commonly measured in decibels.
Now let's make the difference between sound and noise. Noise can be defined as an unpleasant or even dangerous sound. Indeed, what was described previously was a pure sound composed of a periodic signal. In practice, the sounds around us are composed signals. They can be represented using Fourier's formula. A0 imposes the frequency of the sound, i.e. Whether it will be high or low, while the rest determines the harmonics, i.e. the timbre of the sound. Noise, on the other hand, is a superposition of several signals at a given moment which disturbs the initial signal. It is therefore no longer periodic. Here are some remarkable values of the decibel scale. If noise is likely to harm our ears, it is because its sound intensity is too high. In my opinion, above 19 decibels, which is the danger threshold, sound becomes noise. We then notice that the common definition of noise is not the same as the physical definition. Indeed, many noises in the physical sense are perceived as sounds in the common sense, such as the sound of someone's voice.
Now that we have clearly defined noise and sound, let's move on to application. In my opinion, the guitar is a good example to illustrate the notion of sound and noise. Indeed, the electric guitar is connected to an amplifier using an electric cable, jack cable. When the string is vibrating, the electromagnet positioned below will pick up the vibration and via a coil of wire and the jack cable will transmit this vibration to the amplifier in the form of an electric signal, alternating similar to the periodic sound signal, but with an amplitude involved. The amplifier will transform the electric signal into a sound signal. A loudspeaker connected to the amplifier will emit this new signal. It will push the air molecule step by step to our ear. We find here the phenomenon of progressive mechanical waves. However, since the current flowing through the jack cable is weak, other signals can be superimposed on it, such as the Wi-Fi signal, radio, TV, etc. The electric current is then no longer periodic. That generates an unpleasant crackling parasiting the melody. It is a noise. Our